to technical session. First, I welcome the session chair, Mr. Vinay Gupta, Managing Director, Tandon Consultants Private Limited. He is a renowned structural engineer with vast experience in bridges and building design, metro structures, and code development. He has authored numerous technical papers and contributed significantly to BIS and IRC committee. Let's please welcome Mr. Vinay Gupta. Oh, he was just here. Let's wait a few minutes. Meanwhile, Vanessa joins us. I would also like to introduce our speaker for this technical session. Oh, yes. So you have a very long life. So again, I would like to welcome you to the stage to be our first chair for the technical session.
Good morning, everybody. And welcome once again to this August event, that is Seismic Academy, which is initiated by Hilti. And I have known this company for the last 31 years now. Ever since it is Mr. Many Sehmi's times, right? And they have been pioneering, they have been initiating many things about, this fasteners, anchors, and of late now seismic, and so on. And also a codes are being prepared under their the proactive approach. And now we have another proactive person, that is Professor Pradeep Kumar Ramacharla. He is the director of CBRI, and earlier he was, head of the department, Earthquake Engineering Division at IIIT Hyderabad, where my son studied from. Yeah. Now he is, of course, as I said, director of CSIR, Central Building Research Institute at Roorkee. Professor Charla he did his PhD in earthquake engineering in 2001 from University of Tokyo. So I hope you understand what this means. #1 in the world. He joined IIIT Hyderabad in September 2002 and started Earthquake Engineering Research Center, EERC there. He was also instrumental in initiating graduate program on computer-aided structural engineering, CASE at IIIT Hyderabad in 2002. His research interests are earthquake safety, assessment of buildings, as Dr. Shailesh Kumar also mentioned about earthquake safety, historical and critical structures, and capacity building on earthquake disaster safety. And mind you, friends, whether it's Hyderabad, or it is Maharashtra, or it is Delhi, or it is Ladakh, or it is seismic zone 5, 6, whatever you call it, it is utmost important given the place. For example, in 1993, in Maharashtra, in Killari, there was an earthquake, which is supposed to be zone 1, the #1, the lowest. And despite of that, there were damages on account of earthquake. Later on, we elevated the zone to zone 3. So what I'm trying to say is that even if it's a low seismic zone, the disaster safety or safety against disasters is very important due to earthquake. He's a professor. Professor Pradeep is presently supervising 10 PhD students in CBRI. He's published over 100 papers in international and national refereed journals. He has developed the Applied Element Method, AEM, to solve crack initiation and propagation in near faults rupture phenomenon and reduce computational time to understand future possible large earthquakes in Himalayan region. He has developed a new methodology for documenting housing typologies and estimating earthquake disaster risk index of cities. Currently, this indexing method is adopted by NDMA for ranking cities across the nation to understand their relative risk profiles towards launching disaster management initiatives. Now, these words and these sentences may look too long or too lengthy, but the main motto behind everything is, please try and understand earthquake. Please try and implement earthquake engineering in your structures. Please try and implement not only in the design level the same thing, but also in the construction level, which means that the mason, the foreman should also understand the importance of each of the things that we do. For example, you provide cross links. Now these cross links, those people only think that's too difficult. That's a limited domain that they have. But you have to explain them why it is important. Anyway, in association with the NDMA, he developed a prime on rapid visual screening of buildings for earthquake safety assessment. Also, he has undertaken vulnerability assessment of buildings for many state governments and 6 major ports in Gujarat. He is an expert committee member of Post-Earthquake Reconnaissance Team, PERT, of NDMA, Government of India. He is currently a BIS panel member of IS 456, IS 1343, Earthquake Engineering Section Committee, that is CD 39, I think, and also a member of National Building Code of India, which anyway governs the whole country. So with these words, I'll request Professor Pradeep Kumar to please come on the podium and replace me. Thank you.
Thank you, sir, for the detailed introduction. And on a lighter note, nobody can replace you. Your expertise, yeah.
You are a professor who can speak for about 8 hours as well. But the organizers have asked me to not deprive the others of their speeches, and therefore about half an hour for you, 30 minutes.
Yeah. So anyway, the topic is long. I will stop in 30 minutes, whichever slide it is. Okay. So see what I'm trying to tell, that I'll try to conclude it now itself. So we are all in this profession of construction, and then safety should be the first priority. So let us commit ourselves to safety. Let us not take shortcuts. That is the first message I wanted to give, and I'll try to convince you with the slides. Then the second is, which is more important, is be happy in whatever you are doing. So I've taken you to the philosophical statement at 30,000 feet. So be happy in whatever you do. Let today be in your control. So these are the two things with which I would like to start. So earthquake safety assessment of buildings with reference to BIS codes. So I'll tell you what are the challenges, what are the possibilities, and some examples. With some examples, I'll try to tell what we could achieve, and there are many more things which can be done. So let's start with, these are the items which I want to present today. You all know this is the prevailing seismic hazard. The current, officially, this is the current one, and soon to be this one. Okay. So from the official hazard map right now, which is there, country is divided into 4 zones, zone 2, 3, 4 and 5. Then if we compute the area, calculate the area, 56% belongs to zone 3, 4, 5, which has a possibility of moderate to severe earthquakes. That means Bhuj kind of earthquakes might occur in 56% of land, and 82% of population is living in the 56% of land. That is another issue. Now this is the population distribution. Population distribution, as you can see, darker patches indicate higher densities, and this is the town planning parlance: village, city, town, megapolis, metropolis, all that. And then giving another term or a word, risk. So in earthquake, risk consists of 3 factors: hazard, vulnerability and exposure. The fact is 99% of buildings in the country are not planned, designed, constructed to resist earthquake. Literally, vulnerability is 100%, 1. So if we remove that V, which is 1, R is H into E. So that we call it as threat. Threat is hazard multiplied by exposure. Then how do we show it in a graphical form or pictorial form? Hazard is, we know hazard map. Exposure is, we know housing distribution map. Result is this one. We need to worry about every red patch. Each patch is one district. We have around 700 districts. So this map should be used for prioritization of our developmental activities, strengthening activities.
Red is threat.
Red is threat, earthquake threat, factual information. Okay, not much calculation. Hazard, housing density, overlap. That's it. Now, having said, these are the some of the economic centers of the country. There are many more. Now, my question is, can we afford a next earthquake in one of these black dot areas? We all know country's economy right now. We are in 4th position. We are aspiring towards 3. 3 is very easy. But from 3 to become 2, we need 6-fold jump. From 2 to 1, we need 10-fold jump. And believe me, any amount we are pumping in the infrastructure, 3 times of that is the contribution to our GDP. That means if we are putting 100 rupees, it is becoming 300 rupees in our economic contribution. Same is true. If there is a damage, that much is removed from our economy. Now, can't we afford right now 4th position? Suddenly India is slipping to 6th position. How insulting it is. Presently what is happening is we don't feel that insult. Right? If somebody is insulting us, we feel, okay, मैं दिखाऊंगा. But somebody is insulting our country, बुरा तो लगता है, मगर करना क्या है? पता नहीं. तो मैं ये बोल रहा हूँ सबको, करना क्या है? आप जो भी कर रहे हैं, साफ दिल से, अच्छे मन से, वही करिए, बस उतना ही. Right. Again, I'll give you some philosophical background to this one. I'll ask you 2 plus 2 how much? Wrong answer बताइए. Wrong answer. What is the wrong answer of 2 plus 2? 100 is 1.
4.
Wrong answer. Wrong answer you tell me. 22. आप बताइए. 5. Sir आप बताइए. Wrong answer. Any wrong answers? Please tell me. 4, 5 wrong answers. 9. ठीक है. Right answer? Everyone 4. So मैं बोलने का मतलब ये है कि सही में हम एक रहेंगे, गलती में अनेक रहेंगे. तो दिस इज द प्रॉब्लम ऑफ आवर कंट्री. ओके, कोई भी चेंज नहीं कर सकेगा. सो नाउ टू अचीव दिस वन, हमको कॉन्फ्लिक्ट में नहीं जाना है. सो दोज आर द थिंग्स विच आई वांट टू नाउ प्रेजेंट टुडे. देयर आर 3 रीजंस फॉर कोलैप्स एंड डैमेज इन द कंट्री कंपेयर टू एनी अदर कंट्री इन द वर्ल्ड who are facing similar kind of earthquake problems or any other disaster. Urban areas, unregulated development. Now, shortcuts are there. Rural areas, large number of houses are self-built. That means our hi-fi knowledge is not penetrating to that level. दोनों में अपनी गलती है. Okay? एक गलती ज़्यादा कमाने की गलती, दूसरी गलती अपनी घमंड की गलती. 2. तीसरी गलती है कि अपने आप को अपडेट नहीं करने की गलती. दीज आर द 3 मिस्टेक्स. सो वी हैव टू रिजॉल्व दीज 3. ओके, ये फैक्ट्स है, बस इतना ही है. डिजास्टर मैनेजमेंट एक्ट 2005 में, आफ्टर भुज अर्थक्वेक, आफ्टर लॉट ऑफ एफर्ट्स, इट हैज कम इनटू फोर्स. नाउ वन थिंग विच इट टेल्स इज पैराडाइम शिफ्ट. दैट मीन्स वी नीड टू फोकस ऑन मिटिगेशन रिलेटेड एक्टिविटीज rather than reactive approach of response and rehabilitation. So mitigation means what? Safety of buildings. Okay, buildings which are coming up now, new, let us assume that they will be good buildings, but big structural stock is already there. So how to assess and retrofit? So unless we give a business spin to that, that is not going to flourish. So we need to give proper business model for assessment and retrofitting. Otherwise वो magic नहीं होगा. Okay, some glimpses I will show. Earthquake behavior, some technical items, damages. After every earthquake we are seeing such kind of pictures. Let's take reference of Nepal earthquake. Unusual ground motion. What is that unusual? Long period. So whenever long period ground motion occurs, main danger is to tall buildings or long period structures, whatever those structures are, and weak buildings anyway, they will collapse in any earthquake. So this is a famous Darahara square in Nepal, long period, collapsed. Okay, long period, the top element collapsed. Tall building, severe damage. Boundary walls, long period, collapsed. So that means what? Earthquake is clearly showing that what it is coming up with. So we can understand easily that these are the things for which we have to protect our building. So for that, relevant clauses are there. The problem is what? We are taking these clauses lightly. So my advice to everyone, whoever is in the field, okay, learn one clause a day thoroughly. Okay, even in dream you will not commit any mistake while practicing that clause. One clause a day, that's all. One clause a day. In an year you will be mastering 365 clauses. Utne nahi hai. Okay, bas one clause a day. Promise today. Now coming to hazard. Hazard का मतलब क्या है? Simple. Hazard का मतलब है level of ground shaking which the building is going to experience. That is measured in terms of acceleration, velocity and displacement depending on what type of structure you are doing it. How it is measured? There are many ways. Okay, deterministic approach is there, probabilistic approach is there, a combination is also there. And there are many approaches which our experts are also generating, but finally they will be categorized into two and combination of the two. Why it is needed? Hazard estimation to understand the behavior of the buildings when it is subjected to ground motion. So, but there are some gaps in it. Okay. Presently, we don't have probability in our hazard map. That means what? A zone 4 near the foothills of Himalaya is equal to zone 4 in the peninsular India. That is the peak ground acceleration. But unfortunately, after how many years that earthquake is going to occur, that point is not included in the hazard map. Maybe down the line, if many people contribute, that also will come into picture. Now, three ways. Macro hazard at a scale of 100, 200, 300 kilometers. इसलिए one city, पूरा city का एक ही PG, peak ground acceleration है. That can be used for all ordinary buildings. Maybe 4-story, 5-story buildings तक we can use that. That is the macro hazard. But थोड़ा और आगे जाते हैं, सिटी प्लानिंग करना है, तो उसके लिए माइक्रो हजार्ड इज नीडेड, बिकॉज वी कैन नॉट अफोर्ड टू लूज आवर इंफ्रास्ट्रक्चर. माइक्रो हजार्ड वर्क्स in the range of that 10 kilometers up to 0.5 kilometers. When it comes to very important structures, you need to go for site specific hazard assessment. It is quite involved process. It is not a child's play. Okay, people who are involved in the practice for many years, maybe for about a decade, they clearly understand what are the intricate details of the site specific. So it gives values up to 1 meter. So that means whole city 1 PGA, that is macro hazard. In city there are different pockets have different peak ground acceleration values, that is micro hazard. For specific, say India Habitat Center region, if you are trying to estimate, that comes under site specific hazard estimation. So in site specific hazard estimation, these are the technical items which are needed. So one is source identification. यहाँ से 300 किलोमीटर के दूरी में कितने sources है, that one, and then we find attenuation relationships. Then finally finding out the peak ground acceleration at the bedrock level, scaling up models, then finally amplification, and then we find out values, design parameters at the surface level. That's how we bring all the knowledge filtered into these 6 steps for getting for what acceleration, displacement or velocity we should design a structure, design structures in, say, in this campus, on this campus. That is the complete procedure. Well-known theories are there. And then what are the important items which are to be taken into consideration in this one? Magnitude, source mechanism, path, local effects. ये सब. अब क्या हो रहा है कि very very important project में last part is missing. Last part is missing. Why? Even a 30-story building, 50-story building without soil structure interaction, we are putting it on the fixed base and doing the analysis. That is a blunder. इसका मतलब क्या है? People who are doing, they have not done their assignments properly in the college or bunked the class. So पढ़ना चाहिए. We have to be well versed. That's what third point number 3, that is lack of awareness of seismic codes of practice. So soil structure interaction is very, very important. So now 16700, that is tall building code, specifically recommends, okay, if building is 150 meters and above, you have to take care of soil structure interaction effects. So soil structure interaction effects में एक simple table बनाया है thumb rule जैसा. So where you need to do for high rise buildings in all 3 categories, soft, medium and hard soil. In mid rise building, medium soil and soft soil compulsory. In low rise buildings don't need that much. अगर details चाहते हैं तो फिर और भी है. So there are 4 types of structures actually. Type A में rigid towers हैं, Type B में pile supported jetties, Type C में framed buildings and Type 4 structures like pipelines. So for every structure there are challenges in terms of when that structure will enter into non-linearity and how many components of that structure enter into non-linearity. Depending on that, we need to take soil properties and design the structure. Design का मतलब है mainly we have to find out the force which can act on that structure. That is very important. Okay. So if we put fixed base, we get some natural period and dynamic properties. But if it is on the flexible base, dynamic properties get altered. So that means what? The earthquake force which structure is attracting will change. So मान लीजिए we are designing for say 10% of weight, that is base shear. But when it is on soft soil, it is attracting 20% of equivalent weight as a base shear, or maybe say 7% of equivalent of base shear. So कम भी हो सकता है, ज़्यादा भी हो सकता है. So let us not play with lives of people who are going to stay, because in a simple example, जब आप मोबाइल फ़ोन खरीदते हैं, if it doesn't work, what do you do? Go and return or fight with that person. But buildings का काम कर रहा है नहीं कर रहा है, we cannot say 1 or 2 days, 1 or 2 years. It has to serve entire life, 50 years. So उस समय गिर गया तो building. So that is the problem. So these are some of the examples. Okay. So soil structure interaction cannot be taken lightly. उसमें some simplified approach I am telling. So that is a simplified structure. नीचे से the same location under that building. Suppose if say during earthquake it is moving. So there are 4 displacements. One is ground displacement, which is UG. Second is base displacement, that is base of that footing or raft, whatever it is. That is the third one is rocking because of the subgrade reaction of the soil. And finally the displacement of the structure. There are 4 items. Presently what we are doing is तीनों को निकाल रहे हैं, एक से काम चला रहे हैं. Okay, it's a blunder. Yes or no? That's all. So we need to upgrade ourselves technically. इसीलिए बोल रहा हूँ how to attack that 1 code clause a day. बस अपने आप को promise करिए. You are serving the profession. You don't need to do anything else. That much is enough. Okay. So low, medium, high rise structure का example है soft, hard and soft, medium and hard soil में. Simple. I'm not going into too many details. Natural period का कैसा change हो रहा है, base shear कैसा change हो रहा है. These blue color boxes are giving the indication. So presently whatever code is there. So in soft soil, if the base shear is 522, fixed base analysis is giving 371 and flexible base is giving 214. Actually that much is attracted force. Okay, only that much. Right. In some cases it will become higher. So this we need to understand. पढ़ना है बस, अपने आप को अप्लाई करना है उसमें. Now you can see these 2 graphs. One is soil foundation structure interaction, that is blue color, and then green color is fixed base. Fixed base analysis results you can see, and how much amplification is taking place when it is on the flexible base. Okay, this is a shift in the period. Okay, period elongates or frequency reduces. So that means what? We are cheating. Okay, client को जो दे रहे हैं actual problem का solution हम नहीं दे रहे हैं, कुछ ना कुछ ऐसे ही बेच रहे हैं. क्यों? अपने ज्ञान की कमी की वजह से. That's all. The moment we acquire knowledge, we become authentic person. वो इम्पॉर्टेंट है. तो हम सबको वी नीड टू रीडेडिकेट आवरसेल्फ टू आवर प्रोफेशन. नाउ कमिंग टू लेवल ऑफ अर्थक्वेक सेफ्टी. ओके, सो देर आर 4 मेथड्स और 4 लेवल्स. सिंप्लीफाइड में 2 मेथड्स है, डिटेल्ड में 2 मेथड्स है, और क्वालिटेटिव 2 मेथड्स, क्वांटिटेटिव 2 मेथड्स. द सेम थिंग इज नाउ इन द न्यू कोड, दैट इज IS 13935, the upcoming code. So it is giving 5, the same 4 are converted into 5. There is a level 0 and a level 5 responses. तो इसको सिंपल तरीके से बताऊंगा. लार्ज नंबर ऑफ स्ट्रक्चर स्टॉक इज अवेलेबल इन द कंट्री. ओके, सो कितना 30.5 करोड़ बिल्डिंग्स आर देयर इन द कंट्री. सबको असेस करना है. कैसे करना है? टिपिकली दिस इज द RVS फॉर्म, रैपिड विजुअल सर्वे फॉर्म. उसमें जनरल इंफॉर्मेशन, दैट इज लोकेशन, एड्रेस, कहाँ पे है ये म्यूनसिपैलिटी, ऑल दैट. सेकंड वन इज बेसिक इंफॉर्मेशन, लोड बेरिंग स्ट्रक्चर और क्या बोलते फ्रेम्ड स्ट्रक्चर. एंड थर्ड वन इज द पेनल्टीज, द वल्नरेबल स्ट्रक्चर फैक्ट. इतना ही रहेगा. Generally 100 points are given to good building, penalty that is negative score, and then finally 100 minus negative is the score of the building. High score good building, low score not so good building. But one important thing is we need to benchmark that. Simple example, benchmarking का example देता हूँ. Blood pressure benchmarking कितना है? 80/120. How it has come? It's not magic. After surveying so many buildings and after looking at the performance of the people, in the health condition of people, that 80/120 is fixed. Exactly like that for buildings, RVS benchmarking is needed. That we did. We surveyed till now, I personally surveyed till now 80,000 buildings, 80,000 buildings in the country. उसका बड़ा न्यूज़ नहीं बनाया है बस. Okay, so this is a typical RVS form, uncalibrated, but calibrate करते हैं तो I'll show you that calibration also. And how the penalties are decided based on the irregularities, that is table number 5, table number 6. By heart कर लीजिए, रट्टा मार लीजिए, याद रहना चाहिए. पहले याद होगा, उसके बाद में समझ में आएगा बस. राइट, याद हो जाएगा, उसके बाद में समझ में आ जाएगा. Table 5, 5 irregularities, plan irregularities. Table 6, 7 irregularities. So these are the irregularities. When they are there, they become penalty points. They are something like, to me they look like शुगर का लेवल इतना है, किडनी में ये है, गाल ब्लैडर में स्टोन है, हार्ट अटैक है, स्टेंट है, दैट काइंड ऑफ थिंग्स. दीज आर ऑल दीज थिंग्स. सो दैट डिसाइड्स द हेल्थ कंडीशन ऑफ ए पर्सन. नाउ फर्स्ट एक्सरसाइज वी डिड इन गुजरात. 20,000 buildings were surveyed. Okay, majority of the buildings were masonry. So if we do the scoring, that histogram of the score, RVS score 0 to 100, x-axis is a RVS score, y-axis is number of buildings in that category. So इसको benchmarking करना है. So we have selected some buildings in each category, mean plus or minus 1 sigma, plus or minus 2 sigma. That means 5 categories are there. Out of that we have selected some buildings. ये हिमाचल प्रदेश में किया था, ये 10,000 बिल्डिंग का सर्वे के टाइम पे 47 buildings we identified and did the detailed estimation. That means geometry properties, soil properties and dynamic properties. वो करके मॉडलिंग किया है बिल्डिंग्स को to match the computer model with the actual ground level situation. We have installed vibration sensors on the building and matched the building model. So finally we could able to get this curve. This curve clearly indicates that what is, depending on the RVS score, what is the correlation with the damage. Okay, ये 10,000 buildings के study करने के बाद ये result निकला है. Imagine a building score is 35 and it is there in zone 5, 0.36 G, you all know. So that means what? Building will collapse. You can see the curves. वो आज के डेट में हमको पता है बिल्डिंग इज गोइंग टू कोलैप्स करके. सो वी कन्विंस द ओनर, टेलिंग हिम और हर कि भाई आपका घर रेट्रोफिट कर लेते हैं तो बच जाएगा. सो रेट्रोफिट के लिए क्या करना है? टेक्निकल सॉल्यूशन तो चाहिए ही. इन एडिशन टू दैट वी नीड कन्विंसिंग द ओनर एंड हु विल पे मनी. ओके, सो रेट्रोफिटिंग में 3 चैलेंजेस है. टेक्निकल चैलेंज, इकोनॉमिक चैलेंज, सोशल चैलेंज. टेक्निकल चैलेंज, ओके, हम कुछ करके टेक्निकल चैलेंज को रिजॉल्व कर सकते हैं. इकोनॉमिक एंड सोशल चैलेंज, सोशल चैलेंज को सॉल्व करने के लिए वी नीड ब्रांड एम्बेसडर्स. ओके, तो अपने देश में आप पता है ना, जो अच्छे आदमी फॉलो करते हैं, जो श्रेष्ठ व्यक्ति करते हैं, वही सब लोग करते हैं. तो हम अपने आप को श्रेष्ठ व्यक्ति मानते हैं तो हम प्रूव करना पड़ेगा कि हमारा बिल्डिंग सेफ है. एंड देन वी शुड टेल पीपल. and if it is not, we retrofit. So we've started retrofitting buildings in CBRI itself first. Okay, so we have demonstrated the technology with that. Then economic challenge, तो इसके लिए थोड़ा कुछ करना पड़ेगा. We have to convince people. So what we are trying to do is, with the support from NDMA, बैंक के साथ, इंश्योरेंस एजेंसीज के साथ ये कर रहे हैं कि लोन लेके रेट्रोफिट करा सकते हैं. मान लीजिए दिस होम ओनर took the loan and retrofitted the building. Retrofit करने के बाद ऑटोमेटिकली स्कोर इंक्रीज हो जाएगा, 85 हो गया. So it means what? In the event of earthquake, damage will be less, slight damage. मान लीजिए 1 लाख खर्च हो रहा है, ओनर सेज दैट नहीं 1 लाख मैं अफोर्ड नहीं कर सकता हूँ, 80,000 में कराना है, तो क्या होगा? स्कोर कम हो जाएगा, थोड़ा डैमेज बढ़ेगा, राइट? अगर सपोज 60,000 खर्च कर देंगे और थोड़ा डैमेज बढ़ेगा, राइट? स्कोर कम हो जाएगा, डैमेज बढ़ेगा. सो नाउ यहाँ पे एक कैच है कि वी कैनॉट अलाउ टू कम लेस देन दिस वैल्यू. यहाँ पे इंटरसेक्शन कैनॉट बी हियर, इट शुड बी ऑन दिस साइड ओनली. सो व्हाई? लाइफ सेफ्टी इज एंश्योर्ड ऑन द राइट साइड ऑफ द रेड कर्व. ओके, लाइफ लॉस इज देयर ऑन द रेड साइड, ऑन द लेफ्ट साइड ऑफ द रेड कर्व. ये एंश्योर करना है. सो दिस वी डिड फॉर वन मैसनरी टाइपोलॉजी. ऐसे इंडिया में 30 बिल्डिंग टाइपोलॉजीज आर देयर, लॉट ऑफ वर्क इज देयर. सो आई रिक्वेस्ट एकेडमिक इंस्टीट्यूशंस, R&D इंस्टीट्यूशंस टू वर्क ऑन दीज थिंग्स एंड पब्लिश. सर 5 मिनट.
Yes, sir.
So with the support from NDMA, we have prepared this RVS, Rapid Visual Assessment forms, which gives the score for 7 building typologies. Another 20 odd buildings are left, typologies are left, so that we can cover. So this itself is covering almost 80% of the country. ये freely downloadable है, RVS Primer, NDMA टाइप करिए, freely downloadable है. This is, मतलब I feel satisfied when I show this one, because this is, I worked hard for this one. 3 काम ही किया है, उसमें एक काम ये है. And EDRA करके Earthquake Disaster Risk Indexing. उसके बाद में after that, and after publishing that one, we went to BIS and tried to convince BIS that to bring this in the form of a standard. So एक working group बनाया है, जिसका I chaired that working group. Within 9 months, we have worked on the code and brought this code, IS 18289. So this also came out of a pain. After earthquake, so many buildings collapsed. That is one part. But there are many buildings which are damaged. But homeowners will have confusion. अभी घर में रहना है नहीं रहना है ना? Because aftershocks में वो building गिर सकता है. Who will tell? Suppose if 10 lakh buildings are there like that, you need a quick assessment. So we have designed again form which simply ensures life safety is there or not there in that building in 15 minutes. So that is this code. So now it is standardized. In the event of next earthquake, this will be used because it is a legal document now. So scope of this is just to ascertain whether building is livable or not after the earthquake. So इसमें एक safety assessment inspectors करके train होना है, 2 or 3 engineers and architects, trained people who can fill that form. And finally, how do you convey the result to public? By putting tag. What are the tag? Red tag, unsafe building, don't stay. Yellow, further inspection is needed. Green, safe building, stay inside. We are telling safe building, stay inside. Okay. Government appointed people who are doing reconnaissance survey, putting green tag and telling that earthquake आया तो भी कोई problem नहीं है. It's a big challenge, no? But we are achieving now with this one. And there is another category of building, black tag. Barricade करो, जल्दी demolish कर दीजिए building को. On what basis we give these tags? This form which is available. Around 30 questions are there in this one. If at least a single red is ticked, building goes into red category. No red is checked, at least one yellow is checked, building goes into yellow. No red, no single yellow, then building goes into green. Safety. That is the stringent criteria. And all this can happen in 15 to 20 minutes. Ab now 1 lakh buildings have to be surveyed. तो क्या करना है? Bring in latest technologies. So we have tried with a drone based assessment, and finally out of these 30 parameters,